This is Mrs. Grove's second part of this video for section 7.1, which is solving systems of equations. I'm going to go over questions number 4, and then I'm going to do the word problem in the back. And then I'm going to leave it to you to do 15 and 22. You can see the answers to all these problems on my website, or you can watch the entire YouTube video to do these problems. So for now, if you have a problem here that you want to check the solution, is this ordered pair a solution to this system of equations? Well, here's your x-coordinate, here's your y-coordinate, and so you're going to check this first equation, and you're going to plug in the x and y. And so you get 2 times 5 minus 3 times 2. And these came out a little blurry. These are equals. Equals 4. So 10 minus 6 equals 4. 4 equals 4. It checks. So this point right here, 5, 2, is the solution to the first equation. Now you want to check the second equation. So we're going to check this ordered pair, 2 times 5 plus 8 times 2 equals 11. And we see that 10 plus 8, something doesn't look right here. 18 is not equal to 11. Okay. It doesn't check. So what that says is the point 5, 2 is not a solution to this system. Now, in this chapter, we're going to be doing a lot of word problems. So I'd like to spend some time reviewing them. We've done them before. Here we have, and this is a problem from the book, and the problem is it costs $15 for a yearly membership to a movie club at a movie theater. A movie ticket costs $5 for club members and $8 for non-members. Now, whenever you do a word problem, I always want you to write the key information. So the key information, and there's a number of different ways to do it, but here we're talking about members and non-members. And so the members of the movie club, they pay a $15 annual membership. And they pay $5 per movie. The non-members, they don't have a membership, and so they pay $8 per movie. And this problem is walking you through how to do this, but these are the steps that I want you to do when you're doing any word problem. First thing you do is write the key information. The next thing you do is you have to define your variables. So we are using X and Y. And always remember units. So this problem says, write a system of equations that you can use to find the number X of movies viewed, after which the total cost Y for a movie club member, including the membership fee, is the same as the cost for non-members. Okay, so we have two things going on here. We have the number of movies viewed. How many movies do people go to? And the total cost spent, and that's going to be in dollars. So we have two variables. Okay. We have our X variable, we have our Y variable. The next thing we have to do is define our equations. We have an equation for members and an equation for non-members. So members, Y is the total cost. They pay the $15 membership fee, plus they pay $5 for every movie they go to. Non-members, their total cost is $8 for every movie they go to. So now we're going to be graphing this system. So the second part of the question is make a table. Make a table of values that shows the total cost for a member, for a club member, and a non-member after paying to see 1, 2, 3, 4, or 5, or 6 movies. Okay, so here's the table for members. So if I go to one movie, 15, 5 times 1, one movie is $20. 2 movies, 5 times 2 is 10, plus 15 is 25. We go to another movie, we add $5, that's 30. Go to another movie, that's 35. 5 movies, 5 times 5 is 25, plus 15 is 40. And 6 movies is going to be $45. Now, non-members. Let's make a similar table. We're talking about 1, 2, 3, 4, 5, or 6 movies. And every movie they go to, they spend $8. So one movie is 8, 2 is 16, 3 is 24, 4 is 32, 5 times 8 is 40, 6 times 8 is 48. So the next step is, it asks you, draw a graph. Use the table to graph the system of equations. Under which circumstance does it make sense to become a movie club member? That's the question we're going to be looking for. When does it make sense to become a movie club member? So let's graph these. Now, whenever you do a graph, I want you to make sure that you label the scales and the axes clearly. Okay? So the X is going to be the number of movies. And so here's 0, 1, 2, 3, 4, 5, 6. And these grid lines didn't come out very well. Okay, hopefully you can see them better on your handout. But this right here is going to be the y variable, which is total movie cost. And don't forget, it's in dollars. So this is total movie cost in dollars. And we're going to be doing these in units of 5. So that's going to be 10, 15, 20, 25, 30, 35, 40, 45, and it does go up to 50. Okay. So notice that I've clearly defined the axes, clearly shown the scales, and now I'm going to take and graph our members. So our members is at 1. Okay, one movie is $20, 2 movies is $25, and basically we're just going up by 5. 6 movies is $45. So now notice that this is the y-intercept, and if I didn't go to any movies, that would be $15. Now we're looking at non-members, okay? And because of the way this graph is set up, I'm going to plot 540, because that's going to be right on the grid line. And then it's going up. One movie is at $8, and then 16, and then 24, and then 32, 40, and then 48. And notice non-members the y-intercept 0. If they don't go to any movies, then they don't spend any money. We draw this line. That is going to be the solution. The solution is 5 and 40. Okay. So that means that if someone goes to 5 movies, they spend $40. And this happens whether they are a member or not a member. Okay, so the question was, under what circumstances does it make sense to become a movie club member? Think about that for a minute. It would make sense to be a movie club member if you go to more than 5 movies. So, the answer is if you go to more than 5, which means 6 plus movies, you should become a member. So if you go to 5 movies, it doesn't matter if you're a member or a non-member. If you go to more than 5 movies, 6 or more, then you should become a member. It's going to be cheaper. And if you go to less than 5 movies, then you shouldn't become a member. And you can see this with this table right here. Okay? If I'm comparing these, okay, 1 movie, it would be cheaper to be a non-member. 2 movies, cheaper non-member. 3 movies, cheaper non-member. 4 movies, cheaper non-member. 5 movies, it's the same. 6 movies, become a member. So you always ask yourself, does this make sense? Right? So you could look at your member equation, and we have $40 is equal to 15 plus 5, okay, times 5 movies. So $40 equals $40. And you can see if I plug in to the non-member equation, Y is $40, and 8 times 5 movies. So $40 equals $40, and it checks. So there is the problem worked out, and you should always define your key information, define your variables, remember units, define your equations. From now, we're graphing. Make sure your graphs have clear labels and show clear scales. Find the solution and write it in a sentence. So that's how you're going to be doing word problems. Now I'm going to go back and finish this worksheet, or these 2 pages. And I think you're going to do fine with these. This first problem, I want you to really remember how to do x and y intercepts. Make that a little bit bigger. So this is line 1. So for line 1, you want to find the x and y intercepts. And this is line 2. Okay, and this is a little faded. That should be negative. And so for line 2, you want to find the x and y intercepts. The x-intercept for line 1 is going to be 2. The y-intercept for line 1 is going to be negative 2. I graph the x-intercept, the y-intercept for line 1, and here is line 1. Make sure to put arrows on them. I'm going to do my checks on this side, and I'll do a check later for line 1. Now the x-intercepts, and that is plus. So the x-intercept is negative 8, and the y-intercept is negative 8. So I'm going to graph there's my y-intercept, there's my x-intercept. I graph that line. And my lines are not drawn very clearly. So you want to find the solution. And what's really important when you're drawing these lines is that you want to make sure that you draw straight and clear lines. So the solution here is going to be -3, -5. And if I had done a better job of graphing my lines so that they were straighter and I had better grid paper, I would have gotten it so that it was -3, -5 is my solution. But I can prove to you that that is the correct solution because I'm going to check it. I'm going to go back to my original equation for line 1. X is -3 minus y, which is -5, equals 2. So that's going to be plus. So -3 plus 5, 2 equals 2. Cha-ching, it checks. Then I'm going to go back to my second equation. X is -3 and y is -5. And that equals -8. So -8 equals -8. Cha-ching, it checks. So that is solving systems using x and y intercepts. And that's a good review of x and y intercepts. So now, for this problem right here, line 1, we're going to put them in slope-intercept form, which is y equals mx plus b. So our first equation is 2x plus y equals 9. Subtract 2x from both sides. I get y equals -2x plus 9. Remember, that's the slope, which is rise over run. So we're going to have -2 over 1. There's the y-intercept, which is at 9. So we're going to come over here. The y-intercept is at 9. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Okay? And I draw a nice straight line, and hopefully it'll be better than the line I did for number 15. So that is line 1. Line 2 is 2x plus 3y equals 15. I subtract 2x. 3y equals -2x plus 15. Divide by 3. Y equals -2/3 x plus 5. My slope is -2/3. My y-intercept is 5. So I'm going to graph that. My y-intercept is at 5. Okay. I'm going to go up 2, back 3, down 2, forward 3, and it hits the other line, so I'm very happy because I know that's going to be my solution. Right? So the solution to this system is where they intersect, which is at 3, 3. And I am going to go and I am going to check that solution in both original equations. So I'm going to check line 1, 2, x is 3, y is 3 equals 9. 2 times 3 is 6 plus 3, 9 equals 9. It checks. I'm going to check the other equation. 2 times 3 plus 3 times 3 equals 15. 6 plus 9 equals 15, and 15 equals 15, and that checks. Okay. So that is the answer to number 22. And that is the complete answer for number 15. So you can see, if you can graph one line, you can graph two lines, and you can solve these systems of equations. So that's the end of the second part. And the third part will be coming up shortly, which is solving special cases.